Hey team, let's go ahead and take a look at this question with these internuclear distance graphs. So I've gotten a couple questions about this, so I figure a video might be helpful for everyone. All right, so what I have circled and marked, this is the full question that was on the AP exam that I pulled this graph off of. And the question was basically figuring out X, Y, Z, what does it correspond with, hydrogen, nitrogen, or oxygen? So the correct answer per College Board is A. So I wanted to give us some insight into that. So this one is definitely a little bit tricky. So first, the thing we can look at, hydrogen, nitrogen, and oxygen, right? All three diatomics. One of the things we always want to think about when we look at those Lewis structures, they love doing these because you have a single, double, and triple. Single, double, and triple are definitely going to tell us, right, the energy being stored there. So I think that part makes sense, that you see nitrogen having the most energy. Oxygen and hydrogen, though, aren't too far apart. And so that's kind of a tricky part. Part of that has to do with the fact that hydrogen is so much smaller than oxygen, right? You know that each hydrogen atom goes to the 1s, and we know that each oxygen goes to the 2p, right? So you've got something with, oh, it does not like me making small dots. Okay, it's got, right, like a 1s and then something else that's got like a 2p. So we have such a difference in size that even though the oxygen has the double bond, the hydrogen makes up for it in closeness. So the other factor in these graphs we have to look for is that internuclear distance, right? So it's not just single, double, but also their size. So if we look here, where these leave off, we can see that the oxygen line, right, the average distance is larger than the average distance between hydrogen, and that again goes back to their size. So, not my favorite question. You definitely have to really look into it, but that is how you look at the difference between hydrogen, oxygen, nitrogen. So I'd like to add something as a comparison. What if F2 had been on this graph? Would we see something that looks different? And the answer is yes. You know that F2 also goes to the 2p, and even though it is a little bit smaller than oxygen, they're going to the same energy level and subshell. So they're near the same size compared to like the difference between hydrogen and oxygen. So here, right, you know that it's a single bond. If you had fluorine instead of hydrogen in this graph, then the graph might do more of like what you had expected it to do, right? You would expect that it would have a smaller dip, but then you would also expect that the fluorine would have a greater internuclear distance, and that would be accurate because of that single bond that you see there. So, hope this helps a little bit. What makes this problem so challenging is that hydrogen.